So I'll set the recording going, and then it can just run in the background. I hope, anyway. And we'll talk a little bit about the outline of the day. But what I wanted to do first of all is introduce myself, because I don't know what you know about me already, but Ricardo may have kind of introduced me to you ahead of today. But I'm an architect. My job title is Digital Director of a practice in the UK called ADP Architecture. We have 5 offices across the UK and then a few internationally as well. So I've kind of come into architecture through a slightly odd route. You're all undergraduates. You all basically sort of left school, maybe had a gap year, and then you found yourself in architecture now, right? Is that kind of roughly true for most people? Yeah. So my route into architecture was very different. I ended up working with Ricardo. So we ran a practice together for a few years. We taught together. Ricardo and I go a long way back. I'm not just some like random guy he found on the street. But before I was an architect, my first degree was in physics and philosophy. So I studied at Oxford, spent 3-4 years writing essays and doing problem sets with the physicists and the deep thinkers of the philosophy world. And then I ended that and thought, well, what do I do with a physics and philosophy degree? And the answer is, well, there isn't much to do apart from teach. So maybe I'll be a teacher. So I taught secondary science for a little while. So that was kind of going all right, but then I was interested in things like graphic design and web design, and this was the early days of application development, web applications, and I taught myself software engineering, because if you've done physics, then software is kind of like a small leap. And so then suddenly I found myself a software developer. Oh, where did this come from? And then, a couple of years later, I was not just a software developer, but in big data sets, because that's where all the money was at that time. So I worked in healthcare data and finance data. And then suddenly it's machine learning is the new thing, and that's where everyone goes. And then, there are many other things, and there might be other things that come through today where, I ran a photography business, and I did work with the police, and there are going to be other things that you might be interested in that might come up in conversation. But basically what happened was everything kind of coalesced into realizing that I'm interested in lots of technical things, really super nerdy digital stuff. And then I'm also interested in artistic, creative stuff, and how people work, and how society works, and how culture works. And I want to think about those questions as well. And turns out, if you're interested in both of those things at the same time, you will not find a career that gives you any kind of satisfaction other than architecture, because it's the coming together of all of those things. So now where I am is I advise architects on questions of digital ecosystems and digital processes, and recently AI. So suddenly I'm in charge of ethics and practice. If you've got questions about AI, we can talk about that maybe this afternoon or over lunch or something. So I'm kind of involved a little bit with the RIBA there. And then because I used to teach and I like teaching, I've ended up basically coming back to lecturing in architecture. So I teach at Oxford Brookes, which is my connection with Ricardo. And I teach on computational design, and then some kind of more mathsy vector approaches, some simulation stuff, some things about optimization, and we might get into some of those things. But today, what Ricardo's asked, and I'm really excited about, actually, I think this is really where a lot of power comes early in your career to get these things right. Ricardo's asked me, could you show and take people on a journey about how we can use some of these digital tools to help our actual architectural design approach? So we're going to spend the day in Rhino, and hopefully, you've got Rhino open in front of you, or you've got access to Rhino, so you can kind of do some of these things as we go. But there are going to be two different ways that you can learn from a session like this. The first is what you might be used to, which is I'm going to do something on my computer, and then you're going to do that same thing along with me, and then we'll kind of all learn together. And there will be times today when we'll do that. We will have kind of like a workshop thing where I'll show you how to do something and then you do it, and then I'll show you how to do something and then you do it. What you'll find, I'm just going to get my notes up here. There we go. What you will find, though, is that that's quite a slow way of learning, and there's a faster way. And the faster way involves, and hopefully you've all got some of these items, a pen and a piece of paper. Do you all have a pen and a notebook or a sketchbook or a piece of paper? Brilliant. And I'm going to suggest that this is, you keep your laptops open because we'll come back to them, but I'm going to suggest this is a faster way of imparting a lot of knowledge in one day, because you've only got me for a day, so you can get the most you can out of me and out of Ricardo and out of, I'm pretty sure your terms are pretty short as well. You want to get the most that you can out of it. And the reason is this. So I can show you something and you can make notes on what I am doing much faster than you can copy what I'm doing. Does that ring true? And what it means is I can cover more ground. And then the other thing is this is all being recorded so that then you can go back during the week and you can watch the recording, you can pause it, you can rewind it, you can see what I did. You can watch it at half the speed, you can watch it at twice the speed. And I'm effectively then under your control, rather than right now, if you miss something that I do and you're in the middle of doing something, it's like learning is like a wave, and you're either surfing on the wave or the wave has crashed over you and you're flailing about in the sea with seawater up your nose, and you've completely missed where the whole of everyone else is kind of 3 miles off into the future, and you're kind of a little bit behind. So pens and paper, way quicker. So I would suggest one of the things that you can do is make notes on commands and processes that I'm using that you think, I'd like to be able to do that. So what did he press there? And then write it down. That's literally what I tend to do. I'll give you a quick... This is basically how if I see someone doing something, this is what I do. I'll put commands in squares, and then I'll say, this is what he typed, or this is what they typed into Rhino. Obviously, it's a bit of a mess, but you can make yours a lot neater and more beautiful than I will. Okay, so I'll pause there. Any questions before we get going and just sort of dive in and see what we can do?
How we structure the day.
Yeah, absolutely. So this morning, we're going to start with basically just picking everyone up on the basics of how Rhino works, because it's a tool like any other tool. If you're a carpenter, you pick up a hammer, you know how to use it to hit things. If you pick up a saw, you use it to cut things. If you try and do it the other way around, you don't get a lot of really great things made out of wood. So what we need to do is just make sure that we understand how Rhino likes to work, and then we're going to go with the grain of Rhino, of how that likes to go. Make sure we cover the basics, and then pick everyone up to the point where we can start to create some complex geometries, but also, most importantly, we want to make spaces. That's what we're about. We're architects. We make spaces for people. So just because Rhino can do a certain thing doesn't mean that we need to learn it. We need to understand how Rhino helps us to create and sketch and explore spatial expressions. So that's really what the morning is all about. We're gonna pick two kinds of spaces to try and create in Rhino. One of which is straightforward and linear, and another of which is very, very curvy. So I'm going to try and push Rhino to two extremes. And I'm going to sort of let you into a secret of my process with Rhino. When I'm working and designing spaces in Rhino, this is what I do, and I'm just going to take you on that journey a little bit. And that's where I'll show you something, and you're going to go with me, and then we're going to go together in these kind of like, we're slow down a little bit. It's not just me pushing information at you and you scrabbling to write it down. It's something that we'll do together. And we'll also cover the most important thing, and I'll talk about this a bit later, but not just getting into Rhino, but getting out of Rhino. How can this actually produce some things that will be useful to us? Because at the end of the year, no one is going to be looking at your screen when you are rotating a Rhino model on the screen. That's not what you hand in. So it's only useful to us as a tool to get something out. Then we'll break, and in the afternoon, we're going to talk about image making, first of all. So how do we make atmospheric and powerful and evocative and conceptual images out of this kind of 3D software? I'm going to give you some examples of external images, internal images, and technical images, all of which I'm hoping you'll see actually have these kind of multiple layers of work that go into them. So there is no button that you click to say, make me an amazing render, make me an amazing technical drawing. There's kind of layers of work, and that will be a theme that comes through for the day. And we'll also talk a little bit about 3D fabrication, because I also want to, we're packing in a lot today, but what I want to leave you with is the ability to not just create flat images, but also to be able to use Rhino as a tool that you can then go to the workshop and say, right, I'm ready to 3D print, I'm ready to laser cut, I'm ready to CNC. I don't know, do you have hot wire machines? Yeah, like, they're really cool. I assume you don't have like robot arms, because there's a whole other way of constructing things where you can have hot wire and robot arms and modeling foam, and it's like, wow, it blows your mind. But it's more than enough to pack in the day. Have I missed anything?
No, I think that's it.
No. Okay, good. Other questions? Cool. You excited? Get going. Call me Chris, whatever, you there. If you've got questions while we go, just put your hand up, shout out, interrupt me, because again, what we want is this feeling of like, you're going to be on this wave and then something will happen and you'll suddenly realize that you're not following anymore. And that's the point at which you just put your hand up, well, I missed something 2 minutes ago, could you go back? There's no point in me just like carrying on if everyone's lost. Okay, cool. Here we are. It's Rhino. Give me a wave if you fired up Rhino before. Yeah, ish. Or have you used things like SketchUp? AutoCAD, I know you have used AutoCAD, right? So you're happy with the kind of 2D world. But the 3D world is just, it's 3 times more. There's not just a flat surface where you effectively are kind of replicating a drawing board. This is something very different. So we fire up Rhino for the first time. And I want to make a point that is quite important, which is I'm going to ask a question. How big is the box? Someone make a guess? How big is it? Well, there's no right or wrong answer. Have a stab.
Like 1,000 by 1,000 millimeters.
1,000 by 1,000 millimeters. Any other guesses?
650 millimeters.
650 millimeters. They're all just guesses, right? You don't know how big this box is. Actually, I will tell you how big the box is. The way Rhino works is that you type in a command, and then that command is kind of like changes the context of your 3D model. And the command happens up here. And I'm going to type in DIST. In fact, I'm going to turn on my key press thing so you can see when I'm holding down Control and Shift and all of that kind of thing. Type DIST, and it's auto-completed me to distance. So now I press Enter, And basically what I've done is I've got, who's this guy? Yeah, there we go. Distance, D-I-F-T, distance, I press enter. And now the thing up here has said first point for distance. It's changed from command to first point for distance. And what that's doing is it's now having a conversation with me. And you'll notice my mouse has changed. My mouse is now no longer the normal cursor. My mouse is this kind of like little crosshair target thing. So the way I think about this is Rhino has given me the ability, and I don't know whether it's the right analogy or not. It's quite a violent analogy, but Rhino gives me the ability to imagine I'm walking around and then I pick up a gun and I load the gun with a certain type of bullet, and then I can fire that bullet. That's how Rhino wants you to think. So I'm walking around, and I go, I need to do something. I need to make some kind of change to my geometry. I need to find out something. I need to do some action in the world. I type that in, and I've loaded my gun with the distance command. And now my gun is loaded, and my crosshairs are trained on whatever. And now I can say, right, what does it ask me? So first point. So I'm going to click on this first point. And down here, I'm going to come to O snap. I'm going to make sure O snap is turned on. And I'm going to, under the snapping command, what you'll see is a whole load of things like end, near, point, mid, int, perp. For me, they're on the left-hand side, but for you, they may be somewhere else. Can you see those? End, near, all those snaps? If you make sure that end is turned on, then as you hover your mouse over this box here, it's going to say, oh, I found an end. I'm going to snap to that. So I'm going to click once, boom. And now the next point is saying second point for distance. So I can go, I'm going to snap to here, boom. And now it's measured between here and here. And now my command has gone back to being a command. I fired the gun, it's empty. So I'm ready for the next command. I've just done my thing, but just above it, it says, oh, you asked for the distance, I'll give you the distance. It's 18.23 millimeters, 323 millimeters. So now I know how big that distance is. And what you'll notice is that's way smaller than you thought, right? So when you first fire up Rhino, this grid that you see on the ground is actually a really small grid. There's a reason for that. By default, Rhino tends to get used by people who make quite small objects like jewelers or people who make little trinkets. So by default, this is like 1 millimeter. One of these little divisions is 1 millimeter. Not very useful for architecture though, right? So we need to make some adjustments to our environment so that we're working at the right kinds of scales. And the first adjustment we're going to make is that we are going to put a rule in our notebook. This is my golden rule. Take a look at this gray sea of nothingness. We never work in Rhino in a gray sea of nothing. We always have some context and we always have something to keep us grounded as to what scale we're at. Because it's so easy in the digital world to lose track of what scale you're at. You build a box, it was 18 millimeters, you thought it was 1,000. We have no idea what scale we're working at. And we need to keep control over that, especially if we're making spatial expressions that have to do with real people. Well, real people have space and they have size and they inhabit the world, right? So the first thing we're going to do is we're going to import a file. And I do this for everything. I have a file and I will email this to Ricardo and he can email it to everyone else. My file is called people. And I can import that file. And what you'll notice is nothing has happened. I typed import, I chose the file, it's got people in it, nothing's happened. Why has nothing happened? Well, because we're zoomed in on the very, very center of this model. And this is 1 millimeter. So we're looking really, really close up at like a little tiny point on the ground. So what I have to do is I have to zoom out, which I use the mouse wheel for. I zoom out, I zoom out, I zoom out. Oh, hey, there's my people. Now I know how big stuff is. Basically, the rule is, if you have a person, we can come back to these people, but this is my lightweight person. I just use him all the time. I know he's 6 foot tall. Everywhere I go, that person is there to help keep me honest about the way I'm working in this digital world. Here we are. So I called him Guy. He's the guy. He's not very exciting. And what might be useful as well is I'm going to come to my grid. I just type grid. And the other thing about this Rhino command line is that it sort of feels a bit 90s, but you just get used to it. It's a very, very fast way of working. Some commands that you make then have other options within them that you can change. So I just type grid. It allows me to change the grid. And what you'll notice is that in the brackets after choose grid property is this thing called minor line spacing equals 1. So what that says is the distance between each of those grid lines is 1 millimeter, 1 unit. So I'm going to click that. I'm going to say, no, make it 100. And now my grid is 100 times bigger. And now suddenly I feel like I'm actually working at an architectural scale. Is this kind of making sense so far? Cool. Now then, I'm just going to delete these other people. Oops. There we go. Press enter when done. Yeah.
How do you set it up so that your command box is at the top and instead of displaying like that? Because I've got this weird thing when I do it, it comes up the side where all those buttons are. And then
Are you using a Mac?
Yes.
That's because you're using a Mac.
I see.
It's the same thing. There will be some things you can't do that the rest of us on Windows can do, but it's just a slightly different interface. You could probably drag it around, see what you can do. Most of the interface it looks very much like something from the 1990s because it is from the 1990s and they haven't really updated it. But that's also because it works and it's quick. And that's kind of what you want. You want less things in the way of you and your expression of spatial design. So we need to start actually building some stuff. And let's put down some context, something to give us some scale. So I can type the word box. And what do you think that's going to allow me to do? It's going to allow me to make a box in Rhino. So it's going to say first corner of base. Basically, it just talks me through the whole thing. After a while, you start having a conversation with the computer. It's way, way better than ChatGPT because ChatGPT just makes up some random nonsense. Rhino is like very, very, very solid in what it does and what it can't do. I want a box. I type box. It asks me to put down the first corner of a base. Okay, let's put down the first corner of a base. Let's put one, I don't know, here. I'm just doing this by eye. I'm not being very exact. Other corner of base, maybe there's a box here. And then the last thing is it's going to allow me to drag my mouse up and set a height. Now I've made a box. Pat yourself on the back. If you're going along with me, then you've made a box as well. If you're just writing down, am I right in thinking that you're pretty happy about how to make a box in Rhino now? Okay, cool, great. Now, once you've fired the gun once, Rhino has a really fast shortcut, which is just if you press enter again or spacebar again, it'll reload the last command. So I don't have to type box again. I just press spacebar, and now I'm into the box creation tool again. And maybe I could use this to make a very, very long and thin box that is nice and tall, like a big wall. Already we've got something slightly architectural, right? There's a wall here. It's maybe a facade of some building. Maybe there's some kind of massing that we've got going on. Maybe there's something the other side of the street. Already we're starting to build like a context within which we can start working. You happy with what we're doing so far? Cool. We can also, and maybe it would be helpful later on today. Do you have access to Adena, the Digimap suites? Yeah? Okay, so what you can do is you can download not just 2D floor plans or site plans of the site that you're interested in, but you can download the building heights of the surrounding 3D massing of the buildings. And we could do that in order to start to create that context. But for now, all I want to do is just kind of play with some much more simple shapes. Now, what if we wanted to have something a little bit more complicated than a box? Maybe it's multiple boxes that kind of intersect one another. So what I've done there is I've put this box and, maybe I'll bring it over here. And this box is kind of, I've done it by eye. I've just basically smushed two things together, and they're kind of going through each other, and it's really messy, and it's just, it's a bit quick. And what I might want to do is I want to say, well, this is one building. I want to treat this like one piece of massing. And so one of the things that we can do is use Boolean operations. Have you heard of Boolean operations before? Yeah? Maybe you've even done this before, but what we can type is Boolean union. And what that will do is take those two intersecting pieces of geometry and make one single piece of geometry that's kind of all tidied up. So now you can imagine that not only can you union things together, let's put a sphere in this corner, and let's put a cone in this corner that kind of like crashes through. There we go. And we could select all of these things, and we could say Boolean union. And what it's done is it's tidied up all this geometry so that these things kind of like all form one continuous piece of solid. Yeah? Happy with that so far? Well, the thing about Booleans is that you can also use them in really, really interesting ways. So maybe I have a cylinder. Again, I'm just typing what I want. I want a cylinder. And there's a cylinder there. And then what I want to do, I'm going to turn my gumball on. By default, Rhino doesn't turn the gumball on, but the gumball is really helpful. The gumball is this thing with the three axes, the three arrows, colorful arrows, that when you select something, it sort of allows you to like drag it and move it in different directions. The gumball has some really, really useful hidden features. I can move this thing, but I can also... There we go. I can move this thing in one direction. I can move it in another direction. I can move it in a plane by using this little square. I can move it just in the XY plane, but not up in the sky. But I can also drag and move this and then tap, not hold, but tap the Alt key on my keyboard. Tap the Alt key. And I don't know if you can see this, but watch my mouse cursor. I tap my Alt key once, and something changes. The first thing that changes is my mouse has a little plus next to it. And what that means is I can drag this and I can copy without having to do Control-C, Control-V, any of that. I can just drag it, tap Alt, and I made a copy. Yeah?
There's a Mac command for that.
It'll be like Option or something.
Oh, yes, it's Option.
Option. There you go. I'm afraid I'm not really a Mac expert, but you'll probably figure it out quicker than I can look it up. Then with the gumball, the other thing I can do is I can rotate. I can rotate this thing freely, or I can constrain it to one of like a 90-degree angle, and I can do that by holding down the Shift key. So maybe let's rotate that 90 degrees, and then let's shift this back so it's kind of intersecting with my original pipe. Now, I could union these together and that would be fine, but the other thing I can do is I can do a Boolean difference. And a Boolean difference uses one piece of geometry to scoop out a shape of another piece of geometry. The way I think about it is like you choose one piece of geometry to be a crocodile and one piece of geometry to be someone's leg. So you choose the crocodile that you want to take a bite out of another piece of geometry. You say what geometry you want to take a bite out of, and then whatever that shape is, it will take a scoop out. So what we can do is Boolean difference, and it will talk us through the command process. Select surfaces or polysurfaces to subtract from. I want to subtract from this one. Press Enter to continue. Select surfaces or polysurfaces to subtract with. Use this one. Press Enter to continue. There we go. And now, objects do not intersect. Well, they do. I'll just offset a little bit. There we go. Boolean Boolean difference. Boolean difference. Thank you very much. I'm going to subtract from this, press enter, subtract with this, press enter. There we go. And now what I have is this much more complex shape. All it came from was just super simple cylinder and another super simple cylinder. And all I did was just take a chunk out of it. But look how perfect and curved this geometry is. Would you be able to draw that with CAD? Maybe. Would you be able to draw it in 3D? Not easily. So there's a process that you go through in order to create more complex geometry, which is not just to start with what you want, but to think about what processes you're going to use to get there. And Booleans are a really, really powerful way of doing that. The other thing I could do is I could say, oh, I'm really interested in this kind of scooped out shape. Wouldn't it be nice to just select that one bit of an object and make a copy of that and use that somewhere else? What I can do is I can hold down Control and Shift, and that will allow me to select just one face or one edge or one corner of an object. I'll just select just this face, Control Shift, and then hover over, and then I can select it. And then I can do exactly the same thing. I can drag this out and tap Alt, and I'm making a copy of just that face, just that geometry. Now, if I showed you this geometry, would you guess that that had come from a Boolean difference of two cylinders that I then just took one face of? You probably wouldn't. You'd probably be thinking, well, how did he make that? What curves did he draw to do that thing? Well, actually, a lot of complex geometry comes from these quite simple operations. And the challenge with Rhino is how can you turn your complex idea that you have in your head into a set of simple operations that are quite straightforward to do. That's often the challenge. And you basically get there by practicing. So here we are. I can tidy things up in my Rhino world. And I'm going to give you this piece of advice for free, which is that layers are your friend. Have you come across layers in CAD? Yeah. Layers in Rhino, very similar, although you can do more stuff with layers in Rhino. First thing we're going to do is I'm going to say simple geometry tests. And I'm going to set the color of this layer to lavender because I like lavender. And I'm going to select these guys here and just say change object layer. And let's say I'm done playing with this idea. I'm happy with that. Let's move on to something else. I'll just hide that layer. The other thing I can do is what you can't do in CAD, which is you can have sub-layers. So you can nest layers inside other layers. So I can say, I'll just delete that one. Come on, delete. I could say new sub-layer, and I can say cylinders, and I'll color this one dark green, sea green. It's a nicer green. There we go. And I'll select the cylinders, and I'll put them in there. Change objects to layer. And now I can turn the whole thing off, or I can turn just one of them off. And what I'm doing is as I'm going, I'm organizing my work. I'm kind of trying to keep my file as organized as possible. And the reason you want to keep things as organized as possible, I'll set this downloading because it's going to be quite a big a big download. I think I'm on EduRAM. Yeah, I'm on EduRAM. That's good. Okay. Is that by the time you end using Rhino to build a model, you might have 3,000 pieces of geometry. You might have 50 different layers. And then suddenly someone says to you, could you apply a material to that? And you go, oh, okay, right. So now I have to manually select 300 different pieces of geometry in my model. Or I might change my mind about something and I want to, change all of the circles to squares or something. If you've got layers, you've actually got control. If you haven't bothered to keep your model organized, you're in for a world of pain. Here we go. I will set this downloading. Actually, I want a couple of different models, probably. I'll come back during the break and download those because I've kept my things far too organized and now I can't find anything. Right, okay. Oh, yeah.
Sorry, could you repeat how you put the objects into a different layer?
Ah, yes, of course. I'll turn this back on again. Basically, once you've selected an object, let's take this one, for example. I'm really interested in this one. I want to give it its own layer for some reason. Keep a track of it. Once you know the layer that you want to put it on, I'm just going to make a new one here. It's going to call this interesting 001. With it selected, you right-click on the layer that you want it to go onto, and you choose Change Object Layer. Now, there's another way of doing it, which is you create the layer first, and then you set that layer to be the one with the tick. And then when you create that thing, it'll go onto that layer. So let's say that this thing is going to be a purple layer. Here we go. If I double click that layer, it goes bold and it has a little tick next to it. That means that's the active layer. And then if I create something, what should we create? Let's create a pipe. Boop, boop, boop. There we go. Now it's purple because it's on that layer. And if I wanted to go back to working on the default layer, I could double click that and that would go bold and have a tick on it. Make sense? When you import the people, you will realize that the people are on their own layer because I want to make sure that you at least start with some idea of like, oh, people are on their layer and I can turn them on and off at will. That kind of thing. Any other questions on that as we've kind of got going? Cool. I'm going to hide these guys because they are probably just taking a little bit too much space up. There we go. I'm not sure I like this shape, but we'll just roll with it, right? We'll see what we can do. So in Rhino, and it sort of helps really to understand what's actually going on in the geometry engine behind the scenes. A carpenter knows how to use a tool because he understands how that tool is designed and how it works. And Rhino is, what it is a NURBS-based modeling tool. It's a curve-based modeling tool. For those of you who are like anyone super interested in maths and vectors and did maths at A-level and that kind of thing. Yeah, okay, there's a few people. Right, so a NURBS curve is a non-uniform rational B-spline, which means, in order, non-uniform means that you can put weightings on different parts of a curve to change how it curves. Uniform means non-uniform means that you can put different weightings. Rational means that it has to be made up of real numbers. And that means there are some geometries that Rhino cannot represent because they are not rational geometries. And there are going to be times, and I've had it happen to me, where I've asked Rhino to do a thing and it just says, I can't do that. And the reason it can't do that is not because it's not trying hard enough, it's because maths doesn't let it do it. Because it's not made of rational numbers. What you're asking it to do is not a rational thing to do. It's not made of ratios, literally like a number divided by another number. And a B-spline comes from splines Drawing. There we go. Shipbuilding. Find the image that I have in my mind. Yeah, there you go. If you want to design a ship, ships are made of curves. How do you draw a curve? Well, what you do is you take a thin piece of wood, and then you use these things. This is the thing. It's like a little fish, and it's got a hook on it. And what happens is you pop it down on your drawing board, literally the same drawing boards you've got in year 1, year 2, and it bends that piece of wood into the shape that you want. And if you're an engineer designing a ship, what you do is in your drawing, you trace over where these weights go, the non-uniform weights. You've got some weights over here, some weights over here, and it bends the piece of wood in a very controlled manner. And if you want to come back and redraw that same curve, you just put the weights in the same place and you put the same piece of wood around it, and it will draw that same curve. So what we're doing when we use Rhino to draw curves is exactly the same as ancient shipbuilders. And I'll give you an example of that. So all a straight line is, I can come here, I can pick up a line, or I can type the word line, and it's going to say start of line, and it's going to say end of line. And I can draw a straight line. Brilliant. Are we happy with that? That's what we can do in CAD. All very nice. However, I can create not a line, but a curve just by typing curve, or choosing this little button from my buttons menu over here. It looks like a curve in a sort of backwards C shape with some little dots around it. I type curve, and then it's going to say start of curve, degree 3, sub-D friendly no, persistent close no. Degree 3, kind of important if you're interested in a maths bit, but I'm not going to worry about that too much. But watch what happens when I put some points down when I'm drawing this curve. The first point is exactly the same as this super simple straight line. It goes wherever I click. Nothing's changed so far. The second point I'm going to put down, boom. And then I'm going to move my mouse and watch what happens. Does the curve go through the point that I just clicked? No. Will it ever go through that point? Well, only if I keep going in exactly the same direction. Basically, this curve is now kind of, it feels like it's kind of magnetically attracted to that point, but it never actually reaches it. And then I can put another point down, boom, and then now it's magnetically attracted to 2 different points. Yeah, you see? And then I can put the last point down, click once, and then I'm done. I want to finish the curve here. And it says press enter when you're done. Well, useful. I can follow that command, press enter, and there we go. So now what we've got is a curve made up of a start point, which is absolutely on the curve, an end point, which is absolutely on the curve, but all the ones in between, they're basically pulling the curve towards it, but it'll never actually reach. And this might get frustrating for some people. Has anyone had this experience with Rhino where you're like, but I want a curve that touches the ceiling and then goes down again? How do I make it just touch? Well, if I put the control point there, it's not going to touch there. So suddenly now I've got a different kind of problem I'm trying to solve. And that could be quite frustrating sometimes. There is a way of drawing a curve which gives you that level of control about where you want the curve to end up going, but it won't necessarily give you the same level of control that I've just demonstrated. And if you expand out the curve button with this little arrow next to it, expand it out, the first thing is a control point curve, but the next one to it is the same curve, but it's got the points actually sitting on the curve, and that's called an interpolate points curve. And what it will do is it will say, wherever you click, make sure the curve goes through that point. But, and here's the thing, when you've finished, it will then have to interpolate what these points would have to be in order to get the curve to go where you wanted it to go. Does that make sense? I might need to sort of say that again. But When you interpolate a curve, you say, I want the curve to touch the wall and then go away again. But then the computer has to do some backwards mathematics to work out how far away to put this magnetic control point in order that the curve actually does what you wanted it to do. And really importantly, this curve has exactly the same number of control points as the mouses that I clicked. I clicked the mouse 4 times and I have 4 control points. This, I clicked the mouse 4 times, but how many control points do I have? 1, 2, 3, 4, 5, 6. But I only clicked the mouse 4 times. Was because the computer is trying to work out what's the closest representation to a curve that goes through those points that I can create. And this is exactly where what I was just saying about it has to be a rational number. It's possible to command Rhino to make a curve that goes through this point, this point, this point, this point, and that will just say, I can't find a solution to that. Which is why I suggest that you don't use interpolate curves, you use control point curves. You use these curves because this is the way Rhino wants you to work. And there are other ways to then control this so that it maybe goes where you want it to go. And we can come to those. But this is a much more fluid way of working because now I can click on that curve. I can select the control point. I can change my mind about where that went. I can come back and move it. In fact, it's quite parametric. I can change my mind about the curve that I drew. The next thing, and this is what beginners mostly do, is that when they think about control over this curve, they tend to think control means it goes exactly where I want it to go. Yeah? Like that's kind of what it feels like you're asking a computer to do. Do the thing that I tell you to do. I'm in control here. I'm in command. And in order to have that level of control, what people will sometimes do is they will grab their curve tool and they will say, right, I've got a curve in mind, but it goes like this. And this is what you do with like Illustrator, right? If you want a curve in Illustrator, you end up doing this. And then you're happy and you press enter. And then you look at it, oh, not quite right, not quite smooth enough. So I'm going to go in and I'm going to edit this point here. Whoop, there we go, maybe that's better. And then, oh, actually, no, I want it to go the other way. So now I have to select all of these points and sort of move them. Oh, actually, no, I want this one to go over here. Suddenly, you're in a world of pain because you've got too many of these control points. The other thing is when you start moving, and this is the way Rhino wants you to work, you start curves, and then you turn curves into surfaces, and you turn surfaces into solids. And then solids are what architecture is made of. Everything in architecture has a thickness. You know, nothing's infinitely thin. But the way we could do that is we could extrude. This is like a super simple command we could do. We could extrude that curve. I just type extrude. And what that will do is it'll give me a solid surface that's come from that curve going up into the sky. Like maybe a curvy wall or something. But look at that surface, and then let's compare it to this surface. This surface has, I don't know how many, like 50 control points or something. I clicked however many times I clicked because I wanted that exact level of control. And I was like spamming the computer with control points. One thing you'll notice is that this has a whole lot of black lines on it defining that shape. And that's because it needs those black lines in order to cope with all of the very subtle little wiggles of that shape. This is a much simpler shape. And what you'll also notice is that if I now offset surf, offset SRF, offset surf, to make this surface, this very, very thin paper almost surface, infinitely thin, I want to make it thick. Maybe I want to make it 150 millimeters thick. So I'll just type in 150. When it says select object to flip direction, press enter when done, I'll just type 150 because that's how thick I want it to be. I press go. And there I've got my solid wall. If I do exactly the same command on this, look how many more of these black lines I end up getting. there's two things about that. The first is that this is a lot harder to work with. You're going to ask a lot more of your computer. Your file is going to get super big, but also like your level of control over this is now actually less, because if you want to change your mind about that curve, you have to adjust 30 different control points. Let's just really drive this home. If I offset surf again and offset surf again, there we go. Do you see how my mouse is now just spinning, spinning, spinning? All I've done is just offset the surface twice. In this case, it took no time at all. In this case, wow, now I'm going to be waiting. I might actually be waiting quite a long time. So the decision you make when you're creating these initial curves or these initial lines is that if you limit yourself on the number of control points that you use, your file will be light, it will be fast, it will be easy to work with, and it will take up, 50 megabytes on your hard disk. If you don't give yourself that discipline of reducing those number of control points, you end up with a file that's out of control. Like, this is what I mean when I talk about control. It's not, does the line go where I want it to? What I mean about control is, has the computer just sort of overwhelmed and taken over the idea that, I can just create more geometry. The computer is very happy to just keep creating that geometry. And look how messy that now is. These lines have gone everywhere. There's black stuff everywhere. If you look at a file and it's got this black stuff everywhere, that's how you know someone's lost control. Very final thing on this. I'm kind of laboring the point because in a few weeks' time, it'll be the end of the semester, and you'll be like, why is my model crashing? And the reason your model is crashing is because you made a decision early on that either led you to this super smooth, super neat in control model, or it led you to this black mess. So what I can do is I can say export. I'm going to export this and call this neat. Just to my desktop. I'm going to select this guy, export him. I'm going to say busy. It's going to take a long time. It's going to take a very long time to render. And let's just check. By the way, I did the same set of commands, right? I drew a curve, I extruded it, I offset it, I offset again. Same commands for both of those things. Here's my desktop. Date modified. Where are we? Neat. 236 kilobytes. Busy file, 34.3 megabytes. Same four commands, completely different file size, completely different experience. Hopefully I've made that point now. Any questions on that before we move on? I'm going to delete this, by the way. We just don't need it.
When you use the offset, it gives the top of the curve a curve. The offset.
Yeah.
Why is that?
It depends on your offset options. But let's just take this surface. So I've got a flat surface, and the offset surface command basically takes that whole surface and gives it a thickness. Offset surface, where is it? You've got two options for corners. And the options for corners are that you can have them sharp or you can have them curved.
Yeah.
And imagine if I do sharp, then effectively everything is just going to go out in a straight line at perpendicular angle. Whereas if I do corner round, I'll try that one more time here, offset surface, corner round, then it will do this kind of, it's expanding this shape out by 150, but because you've told the corners to all be round, as soon as you have a sharp thing like this, it will curve around the edge of it. So it's in the options for when you do that command. Cool. I'm going to get rid of all this because that's just going to make my file super busy and not very nice. Another piece of free advice: save your work now. There we go. Okay. So let's apply this to some architecture. Where's the... Here we are. So when you're thinking about, oh, there we go. Make this bigger. Yeah, there we go. Oh, go away. When we're thinking about creating spaces in Rhino, the first thing that you'll notice with these kinds of images is they definitely have a person in. And the reason they have a person in is so that we can have an understanding of scale. So I'm going to switch back to Rhino, and we're just going to use what we already know about creating quite simple kinds of shapes. And we're going to try and recreate this kind of space that has, now obviously what we want is we want light to be coming in here. We want there to be an opening, and we want there to be these walls, and they're quite simple walls. They're simply just big slabs. But how are we going to do that? Well, first thing is that to realize that when you try and copy something, it's okay for it not to be exactly perfect. We're using this as an inspiration. We're not trying to just absolutely copy, millimeter for millimeter what someone else has done. But the first thing is that I always start with just what are my construction curves? What are my curves that I need in order to create this space? So I'm going to make a new layer. I'm going to call it construction curves. And making this space, my curves are all going to be straight lines. So that keeps things pretty simple, right? Construction curves, what I tend to do, and I just have a shorthand for this, is that construction curves are always red. And it means that I can see them in my model. I'm going to switch over to that layer, construction curves. They're always red. And I know, I can sort of understand that there's a pool. There's this kind of pool thing right here on the ground in front of this person. So I'm just going to pop down a rectangle to help me visualize that there's this kind of like a swimming pool kind of shape or something. And we'll come back to that. And then the other thing is I'm looking at that and I'm like, well, okay, there's this really interesting wall that kind of comes up and then comes to a corner here. So I can see that there's, looking at this, there's also this kind of like triangular entrance shape. So I can see that there's a wall behind this person that just goes straight up. So let's start with that. I'm going to draw my construction curve on the floor next to this person. I'm going to hold down Shift, a nice big line like that. There's a line on the floor, and that defines the line of the wall that I'm about to draw. And once you've got a curve on the floor, I can extrude that in any direction. In this case, I'm going to extrude it up, extrude curve. We've already looked at that. Now I'm extruding the curve, and oh no, I'm on the wrong layer. So now what I want is a surfaces layer because I'm moving from curves to surfaces, and I might keep moving between these two layers quite a lot. So here we go. I'm going to switch over to my surfaces layer. I'm going to extrude that curve. I'm going to drag it up. I'm just guessing at this point. I'm really trying to be free in the way that I'm designing this space, but I'm also trying to be controlled, right? Being free and controlled all at the same time. It's quite a difficult way of working, but I'm not going to lose my mind over exactly how many meters this is, exactly how many millimeters this is. Now I could, if I wanted to, I could type in a number. So I could say, I know that this wall is 30 meters high. So I could type in 30,000 and press enter. Feels a bit big to me, so my guess was obviously wrong. So actually, I'm going to trust my eyes much more. I'm going to say extrude this curve. Let's go up to about there. There we go. Something like this. So now I've got a surface. It's just a plain surface. I'm not going to worry too much about finishing it off. But then I do know that I've got this interesting thing here, which I've got an entranceway that goes from the corner of this pool, and it goes up and it meets that wall. So already I know I've got this quite interesting little moment. And how am I going to do that? Well, what I'm going to do is I'm going to draw a line on my construction curves layer. So I'm keeping clear what layer I'm on. I'm going to draw a line from here. And I know it kind of comes in a little bit. And I know it sort of hits about there. I'm going to draw it on the ground, just flat. And press enter. So here I am. I've got my line. But then what I can do is I can change my mind about where the end of that line actually goes by selecting the end control point of that line. And the way I can do that is I can simply tap it, and then I can click at the end and choose the curve point. I'll do that one more time. I can select the line, and then that highlights that there's a curve point there and a curve point there. I can select that control point, and now that's the only bit I've got. And now I can drag it up using the gumball. So now I've ended up with drawing this line that moves a little bit in that direction, a little bit in that direction, and a little bit in that direction. And I've done it just by drawing the line on the floor and then dragging the end up. It's kind of a very CAD-y way of doing it, but I'm basically building this kind of very simple wireframe of a space. It's quite quick way of working. What else have I got going on here? Well, I can see that where that hits that wall, it then is going to come out in a straight line that, I mean, it's difficult to tell the perspective here is all a bit off, but, you know, let's just pretend that actually that line comes straight out. And what I can do is I can use this thing called Smart Track. Make sure Smart Track is turned on. And what that will do is gives me the ability to draw this line in the XY plane that comes out like this. Boom. So I'm kind of starting to design this space, right? And I'm using my perspective viewport to do it. And then the next thing is that I know I've got some light coming in. I can't actually see where this light comes from, where it comes in. But I'm assuming it must be some kind of north light. And so clearly what I'm going to have is a copy of this line. I'm going to tap Alt. I'm going to drag that line up, maybe up to about here. And then I come down here and I can see that I've got another one of these kind of bulkhead things and then a line that goes here. So what I need to do here is I need to take this line here and instead of copying it up, I'm going to bring it across, tap Alt, make a copy, maybe to about there. I don't know. We'll see how this feels. I can also take this and I can select that end control point and maybe drag this out a bit further. Do you see I'm picking the most simple, straightforward curves that will define my space, and then I'm going to fill them in with surfaces. You're kind of following how I'm working. And I'm not trying to go into any huge detail. And then I also know that I've got this same thing. Basically, this curve then kind of comes down like this, and then that defines the top of a wall that's on my right-hand side. So what I can do is I can copy, just tap Alt, copy this curve out like that, and then down a little bit. So we can end up joining those together. And then I know this curve is going to be copied down to the ground. Now there's a really useful command to copy that curve down to the ground and put it exactly on the ground plane. And that command is project to C plane. And a C plane stands for construction plane. My construction plane is actually defined by the grid that I'm looking at. The grid is on the ground in this view. So my construction plane is the ground plane. So what I can do when I project to C plane is it says basically flatten whatever object I select down to whatever plane I'm working on. And in this case, I'm working on the ground plane. That's where my grid is. So it says select object to project. Select this one, press enter when done. Delete input objects, no or yes. Well, I'm going to say, no, I don't want to delete that one because I'm using that. I just want to make a curve version of that, but it's down on the floor. So I'm going to say, no, please don't. And now what I have is this line here and this line here. This line here is a projection of that line down onto the floor. It's an exact shadow. So I know they're in line, and I know, therefore, that if what I wanted to do was create some kind of wall that went straight up between this line and this line, there's a couple of ways I can do it. The first way I could do it is I could select this line and extrude it up. You've already seen me do that. A bit boring. You don't need to extrude every time. What we can do is we can actually now use these construction lines to create surfaces that are much more complex by using the loft command. Architects and Rhino love lofting. Basically, almost everything that I do in Rhino could be done with lines and a loft command. If there's one command that you need, it's learning how to draw a curve and learning how to loft between two curves. Because that's basically all of Rhino in a nutshell. We joke, don't we, Ricardo, that your CAD skills are basically limited to, 3 commands in CAD, and that allows you to do everything you need. If all you knew in Rhino was how to draw lines, how to draw curves, and how to loft, that's all you need. You don't need to learn what every single one of these millions of buttons do. If you've got is a workflow that really works. I'm going to come back to here and go to ghosted. Ghosted? Come on. Ghosted. There we go. Okay. So I'm going to select 2 lines. I can hold down Shift to select more than one line, just like in CAD. And I can type loft. And I'm going to make sure that I'm on the right layer, which is the surface layer. And it says loft options. Style, normal, gives me a whole load of boxes I can tick. And align curves, do not simplify, blah, blah. I'm just going to select the default stock options and press OK. So now I've lofted between 2 curves. It's basically giving me the same as if I'd taken that curve and extruded it. But if I take this curve and extrude it, it only goes up. And I don't want to go up. I want to go across. I've got this kind of bulkhead thing that I've got to build in somehow. So how do I make a surface that goes between this line and this line? Well, easy. We loft. I want to go between this line and this line. Press enter when done. Boom. There we go. Now what do? I want to go between this line and this line. Boom. We're done. Are we creating architecture? Yeah, we're getting there, right? And all I started with is just a handful of lines. I chose the most important lines. Here we go. This line and this line. They're lofting. Now there must be an opening in here. This must be some kind of north light to let the light in, right? So I'm going to do a couple of things. The first thing I can do is I can start to make use of, let's just finish this off. Let's probably put another line on my construction curves that goes a bit further back than the pool. Something like this. Do you see we're kind of making this like paper model? It's a little bit like your little maquettes or like a sketch model or something. Loft between this line, and this line, and this line. Loft. There we go. So we've got our opening, our kind of triangular opening. We've got it going up into the sky. We've got it coming down, and we've made all these surfaces. And now what I can do is if I really want to recreate that view, I'm going to make sure nothing's ticked, come into my properties, and I can change the focal length of my camera. At the moment it's 50 millimeters, but if I take that down to something like 24 and zoom in, I'm much closer to getting the kind of view that you saw in that image, right? Now, I'm pretty sure if you're following along with me, you won't have created exactly the same thing that I've created, and that's okay. We're just using this to kind of explore the idea that you can create space pretty easily. And the way in which this is a way of working is like, I think of it as like my paper card kind of way of working. I've just got these lines and I just loft between them, and each loft is a piece of card that I can stack up. And let's just punch a hole. Let's punch a north light in this to let some light in. And the way we're going to do that is that I can double click on any one of these. Oh, there's a question. Yeah.
When I try and shade, it says in safe mode, default shading is disabled. How do I?
Oh, have you switched to ghosted or shaded? Shaded is the one that's giving you problems, is it?
Yeah.
Interesting. It might be a graphics card issue or something. Are you using a university computer?
Yeah.
Have a look over your Christmas tree for a sec.
It's not something that rings a bell. Oh, go back to standard. Drop down your perspective viewport and switch that to. Do you have an option for flat shade? No? That's weird. You've got no viewport options. Okay, try perspective. Try going to display options. Oh, Rhino is started in safe mode. You might need to save that file, restart Rhino, and try and make sure that it doesn't start in safe mode. But everyone else has got the ability to use their kind of graphics stuff. Okay, click no. Save that file to your desktop or somewhere obvious. I think, yeah, that safe mode thing means that you've got a whole load of stuff that no one else has. Now, I did notice another thing, and this is something that happens a lot with Loft. I'll do a little demonstration over here. I'm going to take a straight line and another straight line, and maybe I'll lift one of them up. There we go. And I'm going to loft between them, and I type loft, and I go from this curve to this curve, and I get that. Has anyone got that? Yeah? Yeah, a couple of people do. And what's going on is that this is like, imagine a sheet, and you're holding one end of a sheet, and someone else is holding the other end of a sheet, and then one of you does this. That's what's happening. And the reason is this. I typed loft, and I clicked this end of this curve and this end of this curve. And what the computer thought I was trying to do was to match that end with this end, and that meant that this end and this end have to match up. So you've ended up with a twisted surface. And that surface is basically like impossible to actually make. It's going to give you all sorts of problems. And it also doesn't look like what you wanted. So what you have to do when you're lofting between two curves is you have to remember to click the line at the end that you want to match up with. And then it'll give you a nice, neat thing. Is your Rhino restarting?
I thought I just followed.
Oh yeah, cool. Try going on to another computer in the meantime, probably. Okay. So lofting is all cool, but sometimes with pieces of paper, you make holes in those pieces of paper, right? So what you can do is you can double click on perspective view, and then I've got access to 3 other different views. I've got a top view, I've got a front view, and I've got a right view. And this right view is going to be really helpful for me because this right view allows me to draw a rectangle I'm going to draw a rectangle that basically punches a hole through, there we go. Let's say that there's a roof light in the top of there. And I want you to notice that I've drawn that rectangle just in space using this viewport. It isn't actually touching this surface. It's just come in like basically in the center of the file. But when I look through this viewport, they look like they're overlapping. They're not actually touching in 3D, but they look like they're overlapping. And what I can do, if I switch this to ghosted mode, is I can select this viewport, select this rectangle, and I can type trim. And what it's going to do is allow me to use that rectangle like a cookie cutter to cut out some other geometry. Kind of like the Boolean thing we were doing before, but this is with curves and surfaces. So I can type trim, and it says select object to trim. Press enter to clear selection and start over. So what I want to do is I want to be able to select the object to trim. I'm actually going to switch back to wireframe mode so I see through this. And I'm going to select this surface here, which is this one, this surface here. But I'm selecting it in the right viewport, in the same viewport that I selected that rectangle. And then what happens is it uses that curve like a cookie cutter to make a hole in that surface. You with me? And this is a really, really powerful technique. And the reason it's so powerful is because you can have a line that isn't anywhere near your geometry, but in a certain viewport, it looks like it's cutting through, and then you can use that like a cookie cutter. So here we are. We're kind of getting somewhere, aren't we? And it's now 11 o'clock, and we've created this space. Now, what would be really nice would be to have maybe a floor. So I'm going to put down a box that kind of goes like this, and then I'm just going to drag the box down into the ground so I can kind of see that this thing has some depth. And then the other thing I'm going to do is I'm going to turn the sun on just by typing sun. And then I'm going to turn on the sun, and I'm going to turn on manual control. And then I'm going to come in here and change my viewport to rendered. And everyone gets very excited about rendered. We use the ghosted viewport or the wireframe viewport to actually model things. And then we want to see how this thing is going to behave. We come in here and we change that to a rendered viewport. And now that the sun is on, I can also type lights. And that'll bring up my lights panel. And I can turn off the skylight, or I could turn it down, actually, is probably the easiest thing. I can turn down the skylight so my sort of overall just global illumination is a little bit less. And then the thing I want to do is I want to adjust the sun so that it's pointing in the right kind of direction. Now, clearly, this is not always as matched up as we'd like it to be, but do you see where I'm getting to? There we go. And then maybe I need to do some adjustments to my camera lens length. Maybe that needs to be a little bit less than it was before. I need to come in here. I'm going to get rid of my lights panel and my sun panel. Whoa. And now probably if you're like me, if you're kind of following along, you get very frustrated by trying to adjust your camera like this, because it's sort of like, whoa, it moves everywhere and it kind of loses things. There's a couple of solutions to that. The first solution is that we can click on an item and come into our standard thing here, and then you're looking for a button that looks like a frying pan with 2 eggs in it. Up here, frying pan with 2 eggs. What that does is it centers my viewport on the selected object. It's zoom selected. And what that will do will put the center of my camera on that particular object. And then that allows me to zoom out and rotate my view until things are kind of looking the way I want them to look. And I've got a lot more control now. So my view has come back into my control. Second thing, oh, by the way, let's just make a hole in the floor where our pool would be. I can just type make hole. Make hole is a super cool command. Oh, make hole. There we go. It says select planar closed curves. I can select this thing I did here. Press enter when done. Select surfaces or poly surfaces. Here's my floor that I put in. That's a box. And I'm just going to punch a hole right through it. And it's gone wrong. Why has it gone wrong? Let's find out again. I might just lift it up away from the surface a little bit. Lift that curve up. Make hole. Select planar closed curves. This one. Center when done. Select surfaces here. Basically, it's given me this kind of cookie cutter thing here. I can just punch through. There we go. There's our hole. And now we can set this up. We can set our view up. And the thing that's really important here is that our view is actually like a human scale view. So I want my camera to be at the same level as a human's eyes, if I can. And there's a useful little thing we can do here, which is that I can go into my perspective viewport with all the other viewports visible, and I can type camera. Type camera, and it says camera object is hidden. New value, show, hide, toggle. I'm going to say, I want to show the camera, please. Show. And then that gives me a control point that I can move in the other viewports to exactly set the view up the way I want it to. Do you see, just bearing in mind, this whole process has been, 40 minutes, start to finish? And we're already having a conversation about how I'm going to get an image out of this. Now, I'm not losing my mind about spending hours and hours modeling every tiny thing. I just want to use Rhino like a little modeling tool. I want to take a snapshot, and then what I'm going to do is I'm going to be pretty happy with this. I mean, it's not very tidy. It's not very exact, but it's got a spatial quality and a shadow quality that I'm really interested in some way, right? And then there's a command I can use, and I use this all the time. In fact, I even set up like a shortcut to this because it's quite a long command, and I don't like to write the whole thing. But for you, the command is hyphen, which means you get a whole load more options, view capture to file. Hyphen view capture to file. I press enter, and it gives me the option to set the width and the height of my image. And it also gives me the option to browse to where I want to save that image. So I'm just going to browse to my desktop. You would save it somewhere much more useful. I'm going to press save, and then it's going to think for a little bit. And then it says image successfully saved as C users, Chris Fu, OneDrive, blah, 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 blah. And it's put it on my desktop. So here we are. It's going to open that up. Here's go to my desktop. Here's my view capture. Now, what do I do with this image? Oh, not that one. That's a rubber duck that I was making for some second years. What do I do with this image? What can I do with it?
Just pause.
Oh, yeah.
Just before you move on to that phase, how is it going with these commands and this phase? Everyone's all right with?
Too fast, too slow.
Okay.
About right. Yeah. Okay. Cool. Because in about 5 minutes we'll go on to more interesting geometry and curve geometry, but I won't go quite this slow. I'm going to go a little bit faster just so that you can just write down the commands and then have a go at your own pace. Yeah. Yeah. I finished. Well, literally, I want to make one point. It's a very, very simple point. I've been going for about 40 minutes. I've made some nice spaces. I'm kind of interested. I've got some sunlight in. I've got an image out of it. And I've got the starting of something. And what I want to do with this image is I want to use a really, really incredible piece of technology that's very high tech. I don't know whether you have one anywhere nearby. It's called a printer. And what printers allow you to do is take one of these and then decide what you're going to do next. This is a point that comes back down to something I see loads of people doing when they get into Rhino. They get into the digital, they spend time in the digital, and they never get out. And what you do see, and I don't know whether you see a lot of people doing this, like maybe people in their third year or whatever, they do this for like 45 minutes. Or they like zoom out and they're like, wow, what a great model. And there's something very, very seductive about the right click and the rotate. That means that you think you're doing work, but you're not actually doing any work. This is my point. My point is the printer is an escape route. It's out of the digital, and it means that you get back to working at the speed of your thought, which is the pen, rather than the slow speed of the computer. I was going to show you this isn't the way I work. Let's find this is how to work. What you'll see here is these lines. This is all from Rhino. These are Rhino lines, but they're super messy. They're not really finished. And what I've done is I've been disciplined, and I've said I've gone for 40 minutes. I've done some work, and then I stopped, and I print screen, and I print it out, and then I get a pen, and I decide what I'm doing. And step one, I tried this, and I was like, yeah, I'm getting somewhere, but let's go back into Rhino and let's try something. Let's try what this is going to be. And step two, okay, what if this cantilevered over here? And what if I had some structure going on here? And then I do this, and I've got a 5-minute sketch. I've got some Sharpie, and I'm not precious about it. It's like this is a process work. This isn't about getting to a final image. And then I go back in, and I can work over it again. And basically, each one of those 40-minute sessions can move on a design from almost nothing to a really articulated conversation that you can take a printout to Ricardo and you can have a conversation about architecture with it. So if it helps, the line is Rhino is like a heist. It's like planning a heist. You've got 3 things you need to get right. You need to get in, you need to do some stuff, steal something from the Louvre or whatever. And then the most important thing about a heist is you've got to get out. You've got to escape, because otherwise you'll get trapped in there, the police will come, and your life will be a prison forever. This is how we get out. We get out by print screen, or literally just take a photo on your phone and do something with it. Or with Rhino, what you can do very, very simply is, even if you've forgotten that command, view capture to file, and get like a file, you could just go wireframe, and you can say Control P, and it will print exactly what you see on the screen to a PDF with the lines and everything. That's exactly what's going on with these lines here. That's why they're so messy, because they're just a wireframe. That's all it is. I'm just using the wireframe as a kind of basis for sketching over the top. So if there's one thing that you take away, is like this, it's a heist. You've got to get in, you've got to do some stuff, and then you've got to get out, because otherwise you'll get sucked into this spinning model of doom. And if you're working together in the studio, maybe buddy up with someone and be like, if you notice that I've spent the last hour just spinning a model, you know what to tell me to do, is go and print it. Okay? Cool. Let's take a break. Having said, get out. Stretch your legs, go and actually get out of the basement and breathe some fresh air. And shall we get back together in 1:30? Cool. Good stuff.
Yeah,
enjoying it.
She wrote it, we got caught up.
But like, I thought, I was just gonna ask how did you add the first?
Oh, I was going to email. I've got my file that I use for everything. I'm always at person. I'll email it to you Yeah, good idea. Coffee? Yeah. What's the best email to use?
RMA 59 at cam.ac.uk.
That's a cool email address. RMA.
Yeah. I don't know.
Ricardo
The way they set up
Matthew Assis. Yeah.
I'll add the person.
There you go.
So you said, yeah?
It's got like 5 megabyte attachment, so it might get caught up in like virus scanning and stuff.
It was RMA 59, wasn't it?
Let me check. But yes. RMA59 at cam.ac.uk.
Yeah.
Nothing?
I'm refreshing on that. Okay, maybe send when you come back off the copy.
If it's Microsoft, it's probably being scanned for malicious software or something. That's. When you come back from a holiday in Mauritius.
Yeah, pasta. I had leftover from yesterday.
Pasta?
I was having a good time.
Yeah, pasta.
Pasta. Oh no. Oh, you did your. Oh, you did very good. Ooh.
To drive the stuff. Or do you draw it in the other view?
They had to. She covered it like she made the handbag.
That works.
Like that's so cute. I don't think I'm see something, but I just thought. Yeah, that's kind of. Those are good as well.
How do you get this snap to the lines? Or how do you do snap? Why actually that's not. See, right.
Yeah, it goes from. I think maybe it's more about afternoon. What do you call it? Thingies where you like kind of run. Oh, yeah. So start taking out. Yeah. I'm so lazy. I kind of lost it. Like what he was talking about. Like I think it's like dirty. I don't really know how to get this on the. Do you know how to do it? You've got the cylinder, not the
Oh no.
or past the ground. I was like, you got the cylinder, like, and then like in the cylinder, kind of. Like in the rolling. Yeah. Is it really? I think it was and then.
You just check control, I think. Maybe
Then
yeah.
the one on control.
Oh, it is. Oh, yeah. Yeah, control kind of makes it into geometry.
And then you can use how that's
Okay, so
so then
oh,
start
then problem.
this one track roll, and then
It's working. I'm not ever put my hand on
that's what we're subtracting from. And then subtracting this one. Oh, what did that mean? I probably like when you say beauty and it doesn't. Hey, oh, that's good. I always think this is best as well. Yeah. I hope it's good that we are in smaller studios, so people say that. It's easier to do stuff like this. Because we'll be able to do it. Yeah. This is like the whole one.
You know what time we're
Yeah.
like,
No,
it's not like when you have before, where you've had you just go for lunch really like, but you sound like this is much easier to work back with.
Do you know?
Yeah. So I want to be out by 12:30 or 1, so I can have lunch in the school.
Not too bad though. I thought it was a sleep like one. Yeah, but up to 7 o'clock. No, I'm actually really interested to get this. Wednesday, Friday as well.
But I think when he does the tutorial trip, he'll be only back in about half an hour for lunch.
I think that's time for later.
So
Oh, yeah,
it's
well,
a bit extra.
oh, my guy's cooking dinner for me. Then we're going to go on a walk and all my colleagues. Oh, it's really exciting. What's the cooking do then? Like the Friday after. Oh. So, okay, nice. We put out for breakfast. That's really good. That's really good. I love breakfast. It's fun. 3 meals a day is awesome. Oh, this is the thing we had fun, right? Wait, we'll tell it all. How like, and like, I don't know, my other one don't sell it on my mind last week. But this week. Oh, that's fun. Is that what this is? Just a block?
You have to edit the lots of geometry afterwards.
Oh, I
Yeah,
know.
so make it look like that.
Sure. Oh, I was thinking like, oh, this looks like I think
I guess it's
so that's not bad. She's like says, I'm always busy. That's not a bit in there. Yeah, my book and I'm going tomorrow morning. Yeah. Because they're really excited by the idea of going to college branch. Oh, yeah, oh my god. And then I look at school. How do you create football? And stuff like that. Once when they dropped me off and last year. Oh, really? And we've not really got it started. Yeah, they get to like actually cool. I think you look like it's going to be to my college thing. Oh. So I think I'm going to meet up with them. Can't research it. And then we'll bring my next following in office to work. So we'll go a bit of a longer. And then the same thing as when we meet up with them for the weekend breakfast on the Sunday. And they're doing Alexis. Oh wow, yeah, busy. Well, I think it's been for a few days next week. We're going to have a couple of studios. Tuesday. So, unable to. How did you guys meet? I'm so nervous. That's fine. Six ones. Oh, really? We're the same principal. We're the same boss. So, the high school boss. We're just kind of friends. Oh, yeah. 6 months. Oh, I see. I don't know. Wow. Apparently we have 2 days now. How do you get that? Ooh, cute. I wouldn't mind if we get those.
Okay.
It's kind of waterproof inside it.
Oh my god.
Oh my god, just keep it together. That's what all that is.
Sure.
Oh, I see. Oh my god. It's like an artsy go. How about you? Would I put you say college or
Yeah.
Yeah, I feel like it feels good. No. I don't know.
But I think she
the meditation.
yeah. I know.
And then you're like, it's kind of like structure. It's like centipede because it's like. Something and then something like I think he joined the class. Like I didn't even know it's like so great, bro. And it's like my time. Yeah, I think it's good. That's why I'm so tired. Like yesterday, I was like,
how about you? Just well, yeah, my friends got to me.
I feel like, I don't know. Like, it feels too chill too.
You can go. You can go watch it. Like you like by the like.
Not a single buzz. I'm like half.
Okay, I need to work out what they are.
Yeah. I can't remember any questions now. I know like this one more questions to ask. So I'm going to waste it.
The end is here, and they're coming out.
For you, that's
You watch it. I don't know how to do that.
And when you draw like
You can basically decide to
square,
forget
how do you make it like?
and then it just like points out. Yeah, I actually did one myself. But like, I found
Yeah.
it easier to draw a box. So technically,
That seems to be the way
it's the box.
Oh wait, ready for tomorrow.
It's right, sorry, five, and that's my mom.
It's not the red place, but I keep saying there's the blue green dragon.
So it's, and then it's slightly.
I checked everything.
Yeah, same. I focus on five. Now we start the race.
Oh yeah. I can't say it. I have that. Yes, so much
Power and you have.
Oh, really? Yeah.
And then I'm like, dismantling it at the end. And I'm like, oh my god, you know Toby.
Yeah.
And he's like, yeah, Toby, like Archie.
No way, really.
Oh, what?
And then I was like, Archie. And he's like, oh yeah, that Toby. And he looks sad. Yeah. He did not remember it either. I was like, Adam, and he's like,
I think he knows loads of that.
oh, wait, that's so funny.
I wouldn't say the person.
No, I didn't. Yeah, do you have an off-purpose as well?
No. I don't know. I think he didn't know that I knew you.
Yeah. I was very big. I was tired. I know so.
We literally live opposite each other.
Oh, okay, that's no.
You know that.
Am I?
Yeah.
I mean, I just like. I have
You're
a
like
yeah, I was like that. But I have to decide if I don't.
Oh, but that's good.
Oh, I love it. You look ill.
No, not yet. Although I feel a bit tired. Yeah, I know.
Okay, my sense forward.
Yeah, I feel like it's getting quite well. I think it's still scary. The guy is
It's really difficult.
I think him and Ricardo can get on quite well.
Yeah, like what's the because like
That'll be Ricardo who
how did you get it? Why is it
I think it's just the second day. I think that's why. That's straight.
You coaching like I think I was like really no, we did have sense point, but it finished at 10:30.
no, but like it's
Yeah.
still not quite sure.
We went out at like
Let's just
yeah,
go back to sure.
Yeah.
5:15. And then we got back. It was only
Okay. You should soon be receiving a wonderful file with some people in it. I want to try and do two things in this next hour, which are it's going to be ambitious, but let's see what we can do. I'm going to make a new layer, and I'm going to call it curves. I'm going to make a new layer here, and I'm call them straight lines. I'm going to move my construction curves and my surfaces as sub-layers under straight lines. So I can basically sort of just drag and drop. And then I'm going to turn that layer off, and I'm going to come into a new just blank layer for curvy things. Because what I want to do is, what we've done so far is taken quite a simple linear structure, and we've gone, well, how would we create this kind of like little space, a little moment, a little spatial quality, just using quite simple techniques of lines and surfaces. That's all we're trying to do. What I now want to do is say, well, what if instead we were trying to build something that had far less straight lines and far more curves? And maybe you sort of go, whoa, calm down. It's a bit much. I'm not sure I'm going to be able to do this. So this is the Zaha Serpentine North Gallery Pavilion. Just look at it. I mean, how do you even go about modeling something like that? How would you even go about constructing something like that? Especially if all you're really able to do so far is just sort of draw a line and then extrude it in a particular direction. Like nothing of what you see here, and even the inside, right? The inside has these amazing like light scoops that are also part of the structure of the Serpentine Gallery. Have you hopefully managed to try and visit this at some point? But the process for this is like almost nothing is just a straight line. Almost everything in a Zaha building has this kind of conversation about curvilinearity and about flow. One of my favorite Zaha projects is not one that everyone else thinks of a Zaha project is their favorite, but it's the Maths Gallery. And let's find a floor plan of the Maths Gallery. Here it is. Can I make this bigger? Come on. Yeah, here we are. Take a look at this room. This room is all about flow. And you've been in a series of design studio tutorials and conversations where you've been pushed to distill a concept that's going to drive your designs. Yeah? So you've been pushed to come up with a concept that then informs the design decisions that you're going to make. And if you take a look at this project by Zaha, it's really clear how the concept has like influenced the decision making. The concept is there's this flow of air across an aeroplane wing. And Zaha does this so well. She puts an aeroplane in the room, and then this sculptural form is basically the turbulent airflow that comes off an aeroplane wing when it's flying. But then it's not just enough to just have that hanging in the ceiling. That doesn't make a concept. What tends to happen if you don't embed the concept in your design is that it gets value engineered out. That you have a conversation with the client later down the road, and then you suddenly realize that there isn't enough money for that. And then, well, what can we get rid of? Well, let's get rid of the plane hanging from the ceiling. Instead, the whole floor plan is then driven by this flow of turbulent air. The layout of the museum pieces is driven by the concept. And so there's almost nothing in this design that could be value engineered out. There's almost nothing that's like dead wood. And so when the client's trying to save money, there's nowhere for them to hide. And that's why when Zaha builds buildings, she says, you're going to spend 16 million pounds on this. And they go, okay. I mean, she used to. Her practice is now a very different kind of practice. But like, those are the conversations that you have with a real client. What you want is that concept to be something that pushes your design forward. When I look at the Serpentine Gallery, there's nothing in here that's a straight line. So how do we deal with that in Rhino? Well, luckily, Rhino is all about curves. It's not just about straight lines. And so one of the things that we can do, and I'm going to just use this as an example. I'm going to spend 20 minutes on this as fast as I can. And then we're going to go into like one of these little rapid half-hour sprints where you're going to use what I've just done and you're going to make some amazing curvy forms. You're going to follow what I'm doing. So I'm going to show you first, and then we'll do it together. We can make control point curves, and we'll make them around this person. And maybe we'll use that same concept. I'm just going to put it out there that I think this is a concept that's really interesting to me about flow of people, about the routes that people take, and maybe the space that people inhabit through time when they're literally moving through a space. And maybe I want to sort of move my view over to the top, and I want to come in, and maybe I want to sort of like constrain that space and then open it out again. And let's look at the Serpentine Gallery. There's places where it kind of gets constrained, and then there are places where it opens out again. It kind of comes down and touches the floor. Look at this. The guttering doesn't need to be there because the roof itself acts like a huge gutter, like a rain sort of guide to make sure that the rain only falls in one place on the roof. So I've got this curve, and I'm going to constrain myself to only using 3 control points for every curve that I draw. And this is my challenge to you for the next little bit. You're going to say only 3 control points per curve. If you need to use 4, you can use 4. Okay, fine. So maybe it opens out, and then it gets constrained. Maybe there's this flow that I've got going on. Maybe this is like a ticket office or something. You simply go in, you buy your ticket, and then you come out. That would be like a nice little pavilion that we could design. And then I'm going to have another curve, the other side, that maybe that comes in, and maybe that has a slightly different constriction. Maybe it constricts a little bit earlier, and it's kind of like forces me down a different kind of route. Again, I'm just going 3 control points. 1, 2, 3. And then I'm going to do something a little bit more interesting. I'm going to put a 3rd line in, and we're going to see what loft does when we don't just give it 2 lines to loft between to make a surface, but we give it 3 lines. So here we are. We're going to make another curve, C-U-R-V-E, and again, 3 control points, and there we go. I'm going to double click out of here. And actually, my camera is toggled, so I'm just going to type the word camera and then T for toggle and turn that off. So I can see now, basically, I've got this quite narrow constriction. Maybe that's a little bit too much. I haven't really got room for like a ticket office there or something. So I'm thinking about scale whilst I'm doing this. I've got my person helping me out. Let's come back. And so far, we've only worked in plan. So what would be really nice here is if we could start moving into the 3rd dimension, and we can do that by selecting our curves. And there's a really helpful command, a really helpful shortcut, which I imagine that you will want to write down, and it's the F10 key on your keypad. F10. F10. And when you have a whole load of things selected and you tap F10, it turns on the control points for those objects. And even if you click away from them, the control points are still visible. And that's really helpful because now I can start to decide on how high up I want to drag different control points in this conversation. And maybe I want this end to kind of open out. Could even bring this one down a little bit. Maybe this one comes up. Maybe this one also, maybe I'll leave that one on the floor. Maybe this one up just a little bit. And this one can kind of, whoop. There we go. Now I can really start to play with some of these in that Z direction. I'm actually kind of interested in what if the roof didn't actually go up like a big arch, but actually kind of like had that kind of saddle to it. So potentially this guy here, let's just move him up a little bit there. And maybe he kind of comes up into the air like that. There we go. Now already I can kind of sense that this scale might be a little bit too big. So what I'm actually going to do is I'm going to select these lines and I'm going to use the gumball. The gumball doesn't just allow you to move and rotate, but it also allows you to scale. So I'm going to use this to scale 1D. I'm just going to push this in a little bit. It's probably just a little bit long for my liking. And when I'm looking around this in 3D, I'm kind of thinking, oh, wouldn't it be nice if this actually really articulated this kind of like upwards, reaching upwards and kind of like guiding someone through. Okay, I've got some lines there. I'm sort of fairly happy. I could come back and change my mind about them because there's only 3 control points on each line, 9 in total, gives me a good starting point. And I'm going to select all of these lines, all 3 of them. I'm going to type loft. And again, I'm going to use the built-in loft options. And what you'll notice is that, and go to my ghosted view, what you'll notice is that now I've got this much more complex curvy shape just from these 3 lines. And there's a lot in there that is kind of inspired by, I'm not copying exactly, but I'm inspired by that serpentine pavilion kind of shape. This area in particular, like you can see that there's this kind of like big swoop and then it comes down, it hits the ground and then it goes up again. This kind of view, really interesting. This kind of like absolute, like starts at the ground and really opens up. Yeah. There's some really nice moments in here. I think this moment here is probably a little bit too constrained. It feels like I'm pushing the geometry just a little bit too much. So what I'm going to do is delete that. I'm going to come here and just relax this move. Just move that control point a little bit this way. There we go. Let's try that one more time. So I'm lofting between these 3 curves. And yeah, I can kind of get behind this. Lovely. All right. Now, your shape is going to almost certainly look very different to my shape if you're kind of following along with what I'm doing at the moment. But we can now start to do some really interesting things with this. The first thing is that let's think about those light scoops. They're punctures in the whole of the roof, and then they kind of bring this light down, and they also are structural. So what we can do is I can come into my top viewport, and I can, let's make an ellipse. Make an ellipse here. And that ellipse maybe is going to go in the direction that I'm wanting people to walk in. And I've drawn that ellipse on the floor. Maybe I want it not to be quite so big. So let's just scale that down just a little bit. There we go. And maybe I want another one of them over here. No, maybe it can go over here. Maybe it can live in this corner. And I'm going to copy this one over here. There we go. Now, the way in which these interior kind of scoopy things are laid out is, let's just take a look at this geometry. What you've effectively got is this elliptical shape, this ellipse at the top. And then what it effectively is like a Boolean operation. So we've got this cylinder that comes down to the ground, but some of the cylinder has been sliced off. So what we need to do is say, well, what order of operations can we find that is going to allow us to make that kind of geometry? There's a few different ways we could do it. The first way that I could think of is a very simple loft between 2 curves. And it would be to do this. It would be to say, let's take this line here, and then we copy that up into the sky. Just go further than the kind of 10th roof. And then what we do is we take this guy here and we select these control points and we drag them up, and then we select these control points and maybe drag those up as well. And you see now what I've effectively ended up with is this shape that's kind of similar to what we had before. Yeah. Now, it's not perfect because the way I've drawn this ellipse is like it's got these kinks in the curves, and it's not quite what I had in mind. Instead, what we could do is, I'll just undo those and let those go back to the ground, is what we could do is we could take this ellipse, we could loft between these 2 curves, and we've ended up with this kind of nice like wing shape almost. But then we can use that same technique about the cookie cutter, which is that come in and have a look on that right-hand side and say, right, I'm going to draw a curve, and it's going to come from under the ground. It's going to come up to about here and then go to about here. So I've drawn this curve, and then I'm going to use this cookie cutter curve to trim this guy here. And now what do I end up with? Now we see. Yeah? Are the secrets of the rich and famous architects being revealed to you before your eyes? You know, it's not that complicated. You just have to know that if you can't do something in one go, you have to find 2 things or 3 things in a row that are going to get you to that kind of geometry. Yeah?
Do you want to follow that?
Yeah, do you want me to show you that one more time?
Yeah, that'd be good.
It was a super simple operation. So what I did was I took an oval shape on the ground. I copied that oval shape up to the sky. Or to be honest, I didn't even need to copy it. I could just extrude it, extrude curve, and extrudes it up into the sky like this. Yeah?
But you lofted it.
I lofted it before. The first time I lofted it because I already had 2 curves. I've got these 2 curves. I can loft between them. Basically, the loft is like the default operation. If I need to make a surface, I just think, well, I need 2 curves and I loft between them and that'll give me a surface. And if they're open curves, it'll give me like an open surface. If they're closed curves, it's going to give me this kind of like wrapped around like piece of paper or something. There we go. Now, what I also have is I have an intersection between this thing and this thing. We'll come back and tidy that up in a bit, but let's not worry too much about that. Then what I said is, well, basically all that's going on is that I've cut this oval shape with a kind of curve that goes up like this. So I've come into my front viewport, which gives me a nice view across the whole thing. And I've drawn a curve that does what I want to do. And I've just picked those points. I can change my mind about exactly where that curve goes. Come into 3D, and maybe I move this along this way a little bit. Maybe I move this along this a little bit. There we go. You know, I can sort of change my mind about exactly where that cookie cutter is going. But effectively, I want to use this curve like a cookie cutter to trim off a section of that lofted surface that I've just made. So I trim, I select that surface, and I had to click it twice because it's actually 2 surfaces, one side, one the other, and go. Now, when you look at the photos, I'm nearly there, but there's something I haven't quite got right. And it is that these things don't actually go straight up. They lean back. They're like leaning back thing going on, which is why the loft is quite helpful, because I could come back, just undo. And instead of lofting between something that's like straight up in the air, well, maybe I just need to shift that. Maybe I need to shift it this way a little bit. There we go. And so now I'm going to go from here to here. I'm going to loft that. And that's not as simple as just an extrude. That's now got this kind of curve and kink to it, right? So I know I'm basically really am just copying the serpentine beneath, but I'm learning quite a lot in the process because I'm making this quite complex geometry out of a simple set of moves. And then I'm going to take my curve and actually I'm going to go there and then there and then where's this going to go? Here, something like that. Maybe I need to bring this down a little bit. Maybe this one can come this way. There we go, something like that. But again, we can play. We can like this is each one of these moves is quite a small one, and we can play around with it a little bit. Trim that. There we go. And whoa, now we're really cooking. Look at that. Now you don't have to trim with curves. Remember, Rhino thinks in terms of curves and surfaces. What is a surface? All a surface is in Rhino is a million curves going between one thing and another. So when you take these 3 curves that we started with, 1, 2, 3, and you said loft between them, what Rhino's actually doing is it's saying, well, there's this curve, and there's this curve, and there's this curve, and I want to basically blend between them with a surface. But that surface is made up of a whole load of curves that go in between, right? So you can trim with a surface or you can trim with a curve. Doesn't really matter. You can trim with either. Here, in this instance, what we want to do is tidy up this sort of chimney thing. We don't actually want this chimney to be sort of cutting through this lovely tent that we've got going on. So what I'm going to do is I'm going to type trim, select cutting objects, and I'm going to use the tent as a cutting object. Press enter, and then I'm going to use the object to trim is going to be this one. Boom, there we go. And now what I've ended up with is the edge of that cylinder thing is now exactly in line with this curved surface of the tent's roof. See? And I'm doing a trim command. You know the trim command from CAD, right? It's exactly the same. It's just it's in 3D rather than 2D. Yeah?
If you were then to move that column, would it cut it in different places?
Right. So one of the things that the way in which I'm working at the moment is that I'm working entirely linearly, which means I've cut a thing. If I then change the curve that I used, it won't then remember that, oh, well, that curve got used to make that trim, so I better update that trim. It doesn't do that. So it's an entirely linear process. Step 1, step 2, step 3, there's my output. It's a bit like this way of working is like clay. You know, you do something in clay, there's no undo. I mean, you can undo in Rhino, but there's no, in physical world, there's no way of like doing Control Z and, oh, remember this. However, there is a really, really, really powerful tool in Rhino, which you might be interested in, and I will demonstrate it now. I'm going to take these 3 curves that I originally did. Whoop. I'm going to copy them over here. Use my Alt key. I'm going to copy my guy as well because I really want to keep myself honest and keep the scale correct. And it's this thing that says record history. I'll show it to you in 2 minutes if I can. And I'm going to turn record history on so it goes bold. And then I'm going to select this and type loft and press OK. And because record history was turned on, the resulting surface and the curves now have a relationship. Rhino is going to remember that these curves come from this, that this surface comes from these curves, which means that I can select that curve. And if I was being organized, which I have not been, and I should, slap my wrist, I should be using construction curve layer to keep my construction curves organized, and it should be colored nice and red. And I'm going to change object layer. There we go. There's my red line, so I can find them again. But I can select that curve control point. I can adjust it, and then the surface is going to come with me. So now I have a parametric model. I can change my mind later about a thing I did before. This is a really cool way of working because you can then see how it's going to actually affect the design if you make a different set of decisions. And you can say, oh, wow, hang on, that's really messed up that, so I can't do that. That's going to have to come over here. Maybe, oh, that's a little bit thin and weedy, so maybe I need to, yeah. You see, like, that record history button is really, really helpful.
Can you just go through that again, so how you get it so you join the construction line for the service?
Yeah, so record history will, when it's turned on, will record the relationship between the input geometry and then the command and then the output. It's down here next to filter at the very bottom. You've got 2 options. So what you do is before you are about to do a command, you turn the record history on. Yeah. Oh, sorry. It's because it's way down the bottom of the screen and you probably have to look over the thing. It's called record history. It's down here. Can I do this? Up. There you go. Can you see that? Highlighted in red. So what you have...
Can you just say something about why do you have your construction lines laid to this?
Right. So this is partly about keeping organized, but also it's about the relationship between this kind of layer of control and then the resulting geometry. If I press F10 on a surface, I end up with tons of construction lines all over the place. So I could, if I wanted to, come in and change those construction lines later, but it's way, way more controlled to change the lines that produce that surface rather than anything else. What I do is these construction lines are on and they're red when I'm modeling. But then when what I want to do is I want to think about spatial qualities or light qualities, I don't want these red lines messing everything up. They're a little bit like the construction lines that you would draw in pencil when you do a hand drawing. So you start with a pencil line and you set up your perspective grid or whatever it is, and then you go into pen, and then at the end you get a rubber and you rub out your construction lines, right? Well, this is exactly the same. This is exactly the same process. It's like hand drawing. You start with them on and you model with them, and then at the end you can turn them off, and then you're looking at a clean model. And you also don't then end up with a layer which contains curves and surfaces. Because then what you can do is you can select all the things on one layer which are just the surfaces, and you can do stuff to those. Whereas if you've got a layer which has lines and surfaces, it gets really messy. Question there?
Yeah, so when I tried it, it's something called dragging broke history.
Yes. So what's happened is that there is now a relationship between the resulting surface and the input curves. However, if you then do something else to the resulting surface, like drag it a little bit that way, it now goes, well, hang on, you've just done two things to get there, and I can only record one step. You can record multiple one steps. Should we do something really complex? Super fun? Okay. And this is where record history gets really powerful. Okay. I'm going to turn record history to always on. So every step of the way, it's recording history. It can get a little bit messy, just be aware, but do this at your own risk. I've got this kind of pavilion shape. I've been able to create these quite interesting complex geometries by lofting and cutting. That's basically what I'm doing. But then I come to Ricardo and we have a conversation about sunlight or rainwater or ventilation or openings or something. I'm like, hey, wouldn't it be great if there was like a panelized sequence of openings across this pavilion? And you think, well, okay, but there's going to be like 50 of them, and I've got to model every single one of them. This is going to take me ages. Well, here we go. Record history is on. What I'm going to do is I'm going to look from above, and I'm going to simplify this shape into just a rectangle that I put on the ground. That's kind of roughly the same aspect ratio, roughly the same sort of size. And then what I'm going to do is I'm going to say planar surface, planar SRF. I'll select that rectangle, type planar surface, and all it does is just creates a flat surface in that rectangle. So now I've got a flat surface and I've got a super weird curvy surface. And they're next to each other, just sitting next to each other. Always record history is on. Then what I want to do is I want to panelize this. So what I'm going to do is I'm going to use the divide command. And it says select curves to divide. I'm going to do this quite fast, so because there's a few steps to it, but this is recorded, so you can come back and do this later with the recording. Select curves to divide. And if I'm careful, I can select just the edge of that surface. Because a surface is just to hold millions and millions of curves. So the edge of a surface is just a curve. So a divide command, in the same way that you divide in CAD, split it into equal segments, same in Rhino. So surface edge, and I say I want 10 in that direction. Boom. So now I've got 10 points equally spaced along that line. Now I'm going to do the same thing. I'm going to divide that edge. And maybe I want 5. There we go. So I've got 5 points in that direction, 10 points in that direction, or 10 segments. And then what I'm going to do is I'm going to draw a little rectangle, and I'm going to use Smart Track for this. I hover over this point until it turns white, and then it allows me to drag my mouse in this kind of gray line that goes either side of it. So I've got control over the orthogonal direction that I'm going in. I'm going to hover over this point until it goes white, and then I'm going to go to the intersection. So I have to make sure my intersection snap is turned on. There we are. So I've got a rectangle now that is exactly 1/10 of that and 1/5 of a tenth of the length and a fifth of the width because I've divided it up and I've used those points. Then what I'm going to do is use a 4-point surface. So actually you can just do 4-point, 4, is it 4, no, oh, just surface from 3 or 4 points. It's like it's just a surface point, that's what it's called. And I'm going to go from here to here to here to here. So I'm snapping to the rectangle that I just drew. And that's given me a little surface. And you think, oh, well, great, fine. But now I can turn my control points on for this surface. I'm going to take that surface point, I'm going to lift it up. Now I've got a much more interesting thing, which is kind of like this curved thing that used to be a square, but I've kind of lifted one of the edges up. And maybe even I could like shuffle it along a little bit so it kind of opens up like this. There we go. I'm kind of happy with that. I kind of like it. Record history is still on, by the way. So if I change my mind about exactly where this is going to go, I could come back and do that. Then I take this and, okay, I want to copy that 50 times across this surface because I want to array this kind of panel, this open panel across the thing. You might be saying, this is going to take ages, Chris. This is going to be really annoying. I have to copy and paste, copy and paste, copy and paste. No, there's an array tool. Array, type array. Number in the x direction. Well, I'm going to go 10 in the x direction because that's how much I divided by. 5 in the y direction. There we go. 1 in the z direction. I don't need to go up into the sky. Just one layer. And then it allows me to pick a point, which is the corner, and I can drag my mouse, and then it's going to give me 50 copies of the same geometry. Very quick. 50 copies. Done. And then go to that corner and press enter to accept. Now, because record history is still on, I can come to this original, this parent object, this original object, and I can move it, and all the other ones are going to come with me. Now I've built a completely parametrically opening set of parallels that open and close to the sun or the wind or the rain or whatever. Yeah? Fun. Now you're going to say, well, how do I get these panels onto this surface? Well, there's a command for that. There's a command for everything in Rhino. It's a really, really powerful one, and it's called flow along surf. Flow along surface. What flow along surface does is it takes a base surface with a stuff on it and then maps those things to a target surface and then puts those things on top of it. And it will bend them to exactly fit. So flow along surface says select objects to flow along surface. And what I want to do is select, please, all of these dudes. But what I don't want to do is select, I have to try very hard not to select the surface underneath. I don't want the surface underneath, and I don't want the points either. Don't really need the points. So let's just unselect those. This is where layers would have been really helpful because you can select things by layer rather than doing it manually like I'm doing, but I'm just doing it as fast as I can. Here we are. And now here's all of my things. And we're going to say flow along, help if I typed it right, flow along surface, base surface, select edge near a corner. And the orientation of this needs to be right. So I'm going to select this near a corner. Target surface, select edge near matching corner. So I have to make sure that I select the matching thing of this kind of simplified version of the surface, which was this bit here. And now what I get is these opening panels. But remember, record history was still on. So I can come back here, I can turn my points on, and now I can say, hey, it's summertime. Let's open up the panels. It's wintertime. Let's close up the panels. Cool, right? And not only is that now something that you can produce drawings from, but like I don't know how I would have made that any other way. These curves are like incredibly complex, right? But it's taken, 10 minutes to do? And how many different commands? Like maybe 3 or 4. I mean, this is a sort of a facetious example, but This is the way that Rhino likes to work, is this kind of like layering up of individual, quite simple commands. Does that hopefully get some way to answering your question? Yeah? Cool, great. Now, because we are practicing what we preach, what I'm going to do is I'm just going to use the hide command. I'm going to hide my original surface. And maybe it'd be interesting to take these original curves and just use the pipe command. And maybe I'm going to make those into like metal pipes that are the structure of this kind of pavilion, something like that. I don't know. So what's the radius of this pipe? 35 radius, something like that. There we go. And now already we can see that we're getting into some quite interesting things here. Potentially what I want to do is I want to hide those construction curves. I want to bring my person out here and I want to select just these panels. And remember, in architecture, nothing is ever infinitely thin. Everything has a thickness. So let's select these panels. But not the pipes, not the structure. There we go. And then we're going to offset those surfaces and we're going to give them an offset. I don't know. These may be made out of, I don't know, bent copper. Think of a thing that you could CNC and hammer into shape, something malleable. And maybe that would have like a 5 mil thickness or something like that. Now, obviously, you can see that just by putting thickness on this quite complex geometry, already my computer is now having to work quite hard. And it's also warning me that I've broken a whole load of history on those objects because I've taken something that was just a simple result and I've added thickness to it, which makes it no longer the same object. So it's given me this warning.
Would you have made the original one thicker?
You could do, but then what you'd have is not just one control point down here, you'd have multiple because it would be a thick thing rather than a thin thing. Whereas this allowed me to kind of adjust my idea about where things should be and then kind of bake it in. But there we are. And I'm going to bring my person over here and I'm going to do something really, really important, which is not just take a screenshot in 3D. Hide this for a second. Not just take a screenshot in 3D. Let's think of the section that we'd want to look at. Maybe a section through here. What we can use is something in Rhino called a clipping plane, which is a 3D section cut tool. I think SketchUp has a similar kind of thing, but the Rhino one is, as always, better than SketchUp. So I can type clipping plane, and I'm just going to put a rectangle on the floor. And then what you'll notice is as I drag this up and down, it's basically cutting through my 3D model, just like a plan view or a section view. So now I can have a whole conversation about how a plan is going to look by cutting through a model. However, I want this to be a section, so I'm going to flip that section, that cutting plane, this way up, and then I'm going to move it maybe this way. There we go. So we can see the person, we can see some structure. I mean, there's going to be secondary structure and tertiary structure, and I'm sure there'll be more stuff. But now what I can do is I can come into, let's go to this view, and you can see that the clipping plane isn't actually active in this right-hand view. So I can select that, go to properties, and then I want to cut the right-hand view. Now that's cut. And what I'm going to end up with now is the ability to create a line weights friendly section cut through the model. And what I have to do is I select all of that, including the clipping plane. I'm going to type make 2D. And that will allow me to take 3D geometry in the view that I'm looking at it. And I've got it in an orthogonal view, so it's a section cut view. And it's going to make a 2D line drawing out of it. Do it for you. Don't even have to go into Illustrator. I mean, you will eventually. Press enter. And I'm going to make sure that clipping plane intersections is turned on. And I'm going to press OK. And it takes a little while to think. And then what you'll find is that it goes into the top view and it's created a line drawing of this complex geometry, which is basically ready and waiting to go for me to do some work on it. And it's even got the thickness of each of these panels. The other cool thing is it's put it on the useful layers for me. I've got curves and I've got clipping plane intersections. If I change the color of a clipping plane intersection curve to purple, there we go. For some reason, select objects. If I go into properties and say display color by layer, then they'll be highlighted purple in my viewport. So now I can see these are the cut lines through my model. And it's a bit messy, but you do a bit of tidying up here. And now all I need to do is select that, type export. Remember, it's a heist. Get in, do some stuff, get out. And where can you get out to? Well, if you like CAD, you can export these lines to an AutoCAD drawing, DWG. Bring it into CAD, tidy up your line weights. If you like Illustrator, you can export this to Adobe Illustrator, AI. Let's send it to line drawing section. Have a little think. And we could say, do it to scale, or you can just do it to no scale at all and just resize it in Illustrator to fit on a page. Up to you. Press OK. And then file is successfully saved as line drawing section.ai. And then that will be something you could open in Illustrator or Photoshop or whatever you want to do. That was quite quick, wasn't it? But hopefully it was like, what's the fastest you can get in, do some stuff, and get out? That's what we're aiming for. Any questions on that while we're still on?
Useful? Very nice.
Yeah.
So on Tuesday we're going to see really exciting propositions.
Oh, yeah.
No square boxes.
I think it might be a useful thing to do. We've got 15 minutes now. We could do one of two things. We could do some questions. If you've got specific things, you're like, how would you go about modeling insert thing here? And I can try and kind of give you some pointers about how we might do that. Or we could do like a little sprint where you get yourself in to Rhino, you load up your people, you have a little play around with some of those lofting and trimming tools, and you see if you want to play around with a record history function, you can kind of push yourself to do that. And basically you go for 15 minutes, and then the challenge is at 12:35 in exactly 15 minutes time, you print out wherever you are, or you screenshot wherever you are, or you make 2D wherever you are. Which one of those would be most helpful to you, I suppose, is the question. Would it be a Q&A thing, or would it be like, let's just have a go and see where you get to? Yeah? Okay. All right. Well,
most people have sort of followed you. Some people sort of
yeah. Well, maybe 15 minutes for you to just say, okay, now I'm not talking. I can take the time to actually just have a go and catch up and see what you can do. And then at 12:35, the shutter will come down and you must print whatever you've got. Is that possible?
Yeah, I think so, yeah.
Okay, cool. And then Ricardo and I are here, so you can ask questions as you go. Yeah? Okay, I'm going to put a timer on the screen for 15 minutes and see how you get on. All right, cool. Don't worry if you're all fingers and thumbs. It does take time. It's like playing an instrument.
The objective is to print out something from a make 2D of what you created in 3D.
Yeah. I mean, that would be amazing. If all you get to is just print screen, that's still good. Yeah. But something needs to come out. Yeah. That's basically it. You're practicing the heist move. Okay, go. I'm going to pause the recording now.